So we just learned about the diagonal lengths of rectangles. So why don't we go ahead and look at an example where we might need to use that information. Paul is training his horse to run the course at a pace of 4 meters per second or faster. Paul rides his horse from D to C to E to B in 1 minute and 30 seconds. ABCD is a rectangle. Did Paul make his goal? All right, so let's just take a look at what Paul actually did. Paul went from D to C, so he ran along there. Then he went to E. Oh, that was not very straight. And then he went to B. And he wants to make sure that he can run that course at a pace of 4 meters per second. So what we're going to figure out is the total distance that Paul traveled with his horse. We might know some of this and we might have to find some of the links. So first he went from D to C, then he went from C to E, and then he went from E to B. So we want to figure out how long each of those segments are. Well, because this is a rectangle, and also rectangles are parallelograms, we know that opposite sides will be congruent. So from D to C, we know that that's going to be 192 meters. So D to C is 192. What we don't know is from C to E and E to B. So what we're going to use is the fact that a rectangle has right angles, and we can just take a look at, oh, the screen doesn't show up very well. Let me get a different color. Okay, so, oh yeah, there we go, pink. So if we take a look at this bigger triangle, it's a right triangle, and let's try to find side DB. And if we know what DB is, I'll show you how we can use that to help us find our missing links, and then we can figure out if Paul was going fast enough. So when you have a right triangle, and if you know two sides of a right triangle, so we know down here is 192, opposite sides are congruent, so we know this is 80. We can use Pythagorean theorem to get our third side, which is the hypotenuse. So we'll use a squared plus b squared equals c squared. Just be really careful, your side C has to be the hypotenuse, and the hypotenuse is going to be opposite of your right angle. So it's going to be over here. So we're going to plug in 192 squared plus 80 squared equals c squared. Well, if you square 192 and you square 80 and you add those together, we get a really big number, 43,264. is equal to c squared. And then to figure out what the value of c is, we're going to undo the square by just square rooting both sides. So when you grab your calculator and you square root that 43,000 number, you get side C, which is dB, to be 208 feet. Not feet, actually we're in meters, aren't we? So we just figured out that from D to B is 208. Well, segment DB is a diagonal of a rectangle. We know a couple things about the diagonals of a rectangle. One, because this is a parallelogram also, the diagonals will bisect each other. So we know that this segment is congruent to this segment. So if we take that 208 and cut it in half, we have, oh geez, you can't even see that. We have 104 and 104. And we also know that the diagonals are congruent. So if this diagonal is 208, then that makes this diagonal 208. And this diagonal is also getting bisected. So we know that this segment is congruent to this segment. So we have another 104 segment right there. All right, so how does that help us out? Do we know what segment CE is yet? Well, if we go from C to E, we can see that that's 104 meters. And then from E to B, that's another 104 meters. So what we're going to do is we're going to add together all the all the meters that he traveled with his horse, and we get 400 total meters. We have to compare that to his pace. He wants meters per second. So what we'll do is we'll take his total meters. He traveled 400 meters, and he did that in 1 minute and 30 seconds. That is a total of 90 seconds. So we're going to take the 400 meters, because we need meter per second. We're going to divide that by 90 seconds. When we divide that out, we get about 4.4 meters per second. So his goal was to go 4 meters per second or faster. So what's happening is he's actually traveling more than 4 meters for every second. So did Paul make his goal? He did. He is traveling fast enough. He's actually going faster than what his goal was. So yes, Paul made his goal. Good job, Paul. And then we even could say he rode a little faster. At 4.4 meters per second.